GloVe, it was also an assignment for you to watch the video, is another way of solving the same problem. And the idea is very simple. You are going to create a global matrix, and this is just a pre-processing step. Create a global matrix, and this is just counting the number of times that word I is showing up in the context of word J. And this is going to end up being a symmetric matrix. The number of times that representation is appearing in the context of word is going to be the same as the number of times that word is appearing in the context of representation. So you're just counting. This is a count. This counting variable is actually your data. Because it's a count, it's always positive. And by taking the log of those counts, and whenever you're dealing with counts, you're going to have heavy tail. So taking the log is going to give you a more normal looking distribution. You take the log. Now, the log of something that is positive could end up being from negative infinity to positive infinity. And then you can model it with some variables. And these are actually your word representations. WIs are the word representations, the same way that you had before. And these BI and BJs are there to help you and make your model symmetric. Because we know Xij is a symmetric model, is a symmetric data or a symmetric matrix. And then what do? You want this to hold. You take the right-hand side minus the left-hand side, square it, and then penalize if this is not actually zero or close to zero. Because you want this to be zero, and your objective function is going to keep adjusting W's and B's so that this happens. But this is a weighted sum of squares. And the weight is trying to take into account that some of the words in the dictionary are really frequent. They appear in each other's context all the time. So you're going to cap that. You're going to penalize this. So compare this curve to this line, to the 45-degree line. If you don't penalize, all of these values that are up there are going to dominate your loss function. And then you're not going to learn anything. So you're going to cap it. The other thing is that some of the words are not that frequent, but they are conveying a lot of information. Those ones you're upweighting. You're giving them a higher weight. And this is your loss function. You minimize that with respect to W's, and W's are going to be your word vectors in the end. This is clear. And this is just GloVe. Any questions about it? Okay, perfect. It turns out that there is actually a relationship between the GloVe model and the skip-gram model. What is that? If you go through the math line by line, you're going to see that the loss function for the skip-gram model is very similar to the loss function for the GloVe model. The only difference is GloVe is using mean squared error as their distance. Here you're using a cross entropy as your distance. And this is distance between two probabilities. And then again, this is just weighted with a different weight. Here you're using this weight. Over there, you're using a different weight. And at the same time, there is also this idea of getting or removing the words that are really frequent. That one, you're doing it by that sampling mechanism. But in the end, there is a one-to-one relationship between the two. Is this clear? So that's the only message that I want to convey, that they are actually related with different distances. Okay, awesome. Now, a good paper in deep learning needs to study what is important to the functionality of that model. Not only you are going to compare with the rest of the literature, and then you're going to compare them on semantic and syntactic and both accuracies, you're going to study what is the importance of your hyperparameters. You made a choice, and then you said, I'm going to go with 300. This is the dimensionality that you are seeing here. Why is that? What happens if your dimension is 200? What happens if it is 400? And then you can see that you're going to plateau at some point. So there is not much benefit to increasing your dimensionality from 300 to 400. The other one is the window size. What context? How many words to the left? How many words to the right? Should I take into account? Then you're going to study this. This one is going to also plateau. And then depending on perhaps the overall performance is the most important thing to you, you're going to choose something around 6. If syntax is really important to you, maybe you're going to choose something around here. So there are all of these trade-offs that you need to take into account. Asymmetric context is when you're only looking at the words to the right rather than the words to the left, or the other way around. Another, I guess you asked me this question, what should be our K when it comes to negative sampling and the escape-gram model. This paper is studying it. The number of negative samples could be 1, 3, 5, 7, 10, 15, up until 50. And then you can see that not only you go up, and then you're going to start to go down. So the more negative samples is not helping you when it comes to continuous bag of words. For escape-gram model, it helps, but the amount that it is helping is not that much. Maybe you want to choose something around 10. But there is a nice behavior here for GloVe. The more you let it train, the better your representations are getting. But then again, this is gonna plateau at some point. Is GloVe clear? Okay, awesome.